GSA Black Holes Part 1. Good morning, ladies and gentlemen. Welcome back to our series of tutorials. And we consider GSA for CSS preparation. And we go along with different topics as we proceed in our videos. How black holes are detected. One way of finding black holes is to observe the matter moving around in an orbit at much higher speed than expected. By carefully mapping the motion, the third law of Kepler and Newton's law of gravitation can be applied without seeing the actual object at the center of the orbit. Another way of finding black holes is to look at them as sources of X-ray radiation. The tremendous gravitational field of the black holes can produce huge amount of light nearby and around itself, even if itself is black. Just as a meteorite or a spacecraft gets hot as it enters the Earth's atmosphere, the falling matter gets hot from the frictional drag too, sometimes reaching temperatures of millions of degrees. That hot material glows brightly and emits far more X-ray radiation and radio waves than would normally be expected from such a small volume of space. Scientists search for such small spaces with abnormally high X-ray radiation to look for black holes. Does hot water freeze faster than cold water? A bucket of hot water will not freeze faster than a bucket of cold water. However, a bucket of water that has been heated or boiled, then allowed to cool to the same temperature as that of the bucket of a cold water, may freeze faster. Heating or boiling drives out some of the air bubbles in water. Because air bubbles cut down thermal conductivity, they can inhibit freezing. For the same reason, previously heated water forms denser ice than unheated water, which is why hot water pipes tend to burst before cold water pipes. What is superconductivity? Superconductivity is a condition in which many metals, alloys, organic compounds, and ceramics conduct electricity without resistance, usually at low temperatures. A Dutch physicist discovered superconductivity in 1911. The modern theory regarding the phenomenon was developed by the American physicist John Bardeen, Leon N. Cooper, and John Robert Schrieffer, known as the BCS theory after three scientists, as their names were John Bardeen, Leon N. Cooper, and John Robert Schrieffer. So the names were given as BCS. The theory was after these three scientists. It postulates that superconductivity occurs in certain materials because the electrons in them, rather than remaining free to collide with imperfections and scatter, form pairs that can flow easily around the imperfections and do not lose their energy. Bardeen, Cooper, and Schrieffer received a Nobel Prize in Physics for their work in 1972. A further breakthrough in superconductivity was made in 1986 by George Bandenzor and KLX Muller. Baden-Nors and Muller discovered a ceramic material consisting of lanthanum. We'll tell you more about the same in the next video.